Okay, so I've been talking about how degrees is for dummies, but we're going to do some degree stuff today. So first of all, tangent of 390 degrees. So if I take a look at my unit circle, or Sam's unit circle, 390 degrees, there's 360 plus 30 more. Does that make sense? So tangent of 390 is the same thing as tangent of 30, because you've got 360 plus 30, really. So the nice thing about the unit circle is that we put the tangent values on the outside. Sam's got hers in orange, so the answer is just square root of 3 over 3, okay? So the answer is just square root of 3 over 3. Now, if you use your calculator and you get a decimal answer, I will definitely mark it wrong because I want unit circle answers and I want exact answers. So if you give me a decimal answer, you're going to miss it, all right? Secant is 60. Secant is 1 over the x value, so we find 60 degrees. Here it is. And we're going to go 1 over the x value. The x value is 1/2. So we're going to go 1 over a 1/2. 1 over any fraction just flips it up. And so we end up with an answer of 2 over 1, which is just 2. All right. I guess that one you could have done on a calculator because you'd get 2 anyway, right? Can't go wrong on that one. Cotangent. So cotangent is either going to be the x over the y, or it could be 1 over the tangent values, okay? Either one. And I'll show you how both work. So if we go to 120 degrees, a positive rotation for 120 degrees is here. So a negative rotation for 120 degrees has got to be here at 240. So the tangent value, you could either do the x over the y, which would be negative 1/2 over negative square root of 3 over 2, or, which I think is easier, is just to do 1 over the tangent value and then simplify that. So I go 1 over the tangent value, it's going to be just simply 1 over square root of 3. And again, we're going to have to rationalize that, you know. We'll multiply by square root of 3 over square root of 3 to rationalize it. And we end up with square root of 3 over 3. And that's the cotangent of negative 120. Again, if you use your calculator, you'll get a decimal. I'll mark it wrong because I want the exact value, okay? Example 2, express sine of theta in terms of cosine. How do you put sine in terms of cosine unless we have a nice little identity? So we do have an identity. Our identity is sine squared theta plus cosine squared theta equals 1. So if we want to express sine in terms of cosine, let's try and solve for sine. So to solve for sine, so I'm going to solve for sine theta. So if I solve for sine theta, we're going to have sine theta equals blah blah cosine, right? So express sine in terms of cosine. So if I solve for my sine, get all this other stuff over here, I'll have sine theta equals blah blah cosine. Well, let's do that. First step, we'll bring over the cosine. The sine square root of theta is equal to a 1 minus a cosine square root of theta. And then I'll just take the square root, because we've talked about how that squares on the outside. So the sine of theta is equal to plus or minus the square root of 1 minus cosine square root of theta. All right. Now that doesn't do much for us yet, but we're slowly going to start talking about doing identities. So when we get to that particular chapter, you're going to be a little bit used to doing identities. Okay, now express tangent in terms of sine. Well, one of the things I know about tangent is equal to sine over cosine, right? So we need tangent in terms of sine, totally. So I want to be able to say tangent of theta is equal to blah 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 sine, okay? That's what I want to say blah 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 sine, right? So I know for sure that I can write it as sine of theta over, but I don't want cosine. I want everything in terms of sine. So I'm going to go back up to what I just did here. And if I solve for cosine instead, then I can put that in place of cosine in terms of sine. So I want to go back up and do the same process I did here, but with the other one. So instead of sine squared theta plus cosine squared theta equals 1, let's solve for cosine, and then I can put that in place of cosine. So let's bring over the sine this time. So we'll go cosine squared theta is equal to 1 minus sine squared theta. I'll square root that, and I'll have a cosine of theta is equal to plus or minus the square root of 1 minus sine squared theta. Now why would I need to do that? Well, because I'm going to put this expression right there into cosine, and instead of having it in terms of cosine, then we're going to rewrite this as plus or minus the square root of 1 minus a sine squared of theta. Alright, let's reread the expression. It says express tangent in terms of sine. It's a little sloppy, it's a little messy, but what I have written down here is all in terms of sine, don't I? There's no cosine, there's no tangent. Tangent is equal to blah 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 sine. Sine over 1 plus or minus 1 minus sine squared. Okay, these are a little bit harder. So we're going to start doing some identities. So I'll back up. What I had to do is first I had to get tangent totally in terms of sines and cosines. And the only thing I know is that tangent sine of a cosine. So then I had to get rid of the cosine. To get rid of the cosine, I used my sine squared plus cosine squared equals 1. I solve for cosine, so I can put that in its place. When I'm finally done, it's all in terms of sine. Just sine words, no cosines, no tangents, okay? Alright, let's flip the page. Alright? Okay, example 4. Now, tangent is equal to 2/3 in quadrant 3. So we're no longer on the unit circle. So no unit circle, okay? That means that the radius has got to be bigger than 1. Let's figure out what it is. Now, anytime I see quadrant 3, I'm going to draw a triangle. Draw a triangle. So let's draw a triangle. But we're going to draw it in quadrant 3. So it doesn't have to be a very fancy triangle. But I do know that's going to look something like this. Your triangles are always flush with the x-axis, because that's how you would graph a point, out and down, right? Back and down to get in quadrant 3. Okay, now tangent, here's what we know about tangent. Tangent is equal to my y over my x, right? We know that. Tangent's y over x. So that means my 2 has to be my y value, and my 3 has to be my x value. Okay, because I know from tangent is my y over x, so that means my 2's got to be my y and my 3 is my x. Yes, thank you, Colby. But the only problem is they're both negative, because in order to graph this point you have to go back and then down, right? So I have to make it a negative and a negative. And that kind of makes sense to me, because negative divided by a negative turns out to be positive. I mean, right? I mean, that's why it was 2/3 here, not negative 2 over negative 3. Negative 2 over negative 3, that'd be dumb, right? We would just make that positive. However, it came from a negative 2 over negative 3. Now, what I don't know is the radius. Okay, let's use Pythagoras theorem to get the radius. So I'm going to go, all right, I'm going to go Pythagoras theorem, I'm going to go negative 3 squared plus negative 2 squared equals r squared, because I need to know the radius, right? 9 plus 4 equals r squared. Or we want to use square root of 13, please. Square root of 13 is r. Let's please use the exact value. Square root of 13, not 3 point blah, 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 okay? So that's no problem. So let's write down what we know, okay? On the sidebar, I know that my x value is negative 3. I know my y value is negative 2. And I know my radius is the square root of 13. The radius is always positive, okay? The radius is always positive because it's a length, okay? So then, let's just do it. Easy. Sine is equal to the y over the r, which is going to be my negative 2 over the square root of 13. Ooh, that's a really ugly answer. Or, how about better yet, negative 2 square root of 13 over 13. Much better answer, huh? You can't have square roots in the bottom. You got to rationalize it. So I just brought it up, okay? Cosine of theta. Cosine's the x over the r, right? Which is going to be my negative 3 over the square root of 13. But that's a bad answer. Ugh, that's pretty ugly. So we rationalize it. We get negative 3 square roots of 13 over 13. That's a much better answer. We already got tangent. I don't need to do tangent because tangent is there, right? But cotangent, let's do cotangent because cotangent is super easy. Cotangent. So if tangent is 2/3, yeah, Ryan's right. Then cotangent theta is just going to be 3 over 2. That was easy squeezy, huh? Because cotangent is the reciprocal. So now if I have to do cosecant theta, well, that's going to be my r over my y, which is going to be my square root of 13 over negative 2. And let's do my secant of theta, which is going to be my r over my x, which is going to be my square root of 13 over negative 3. Okay, that wasn't bad. Please, when you guys take the quiz next week or whenever it pops up, please make sure you keep them in terms of square roots, okay? All right. Example 5. Find the area of this triangle. All right.
Is that supposed to be a 90? Just try to watch how.
Yeah, no, it's not a 90 degrees. In fact, we don't know it at all, but we don't need to know the 90. This is probably one of the easiest problems. We're simply going to go area is equal to 1/2 adjacent times adjacent times the sine of the angle, right? Which is equal to 1/2 14 times 12 sine of 56 degrees. So what kind of mode do you think we're going to be in? I think so. So it's just super easy. Just make sure we're in degree mode, right? On, clear, mode. Oh yeah, I'm in radians. That's not going to work, is it? Yeah, that's not going to work. So I'm going to go 0.5 times 14 times 12 times the sine of 56. And there it is, about 69.64 centimeters squared. Okay, so homework. Make sure you draw the picture, show the work,